In this video we're going to look at how we go from raw seismic interpretation through a structural framework to produce a pillar grid. We will start by setting the perspective. We'll choose Geology and Geophysics, and we'll be working in the Structural Modelling tab. Let's start by looking at our input data. We've got a very nice seismic cube where the faults are very clearly delineated. We can scan through the seismic and we see we have a very clear image both in the inlines and in the time slices. From this data we have picked a set of faults, and then horizons have been added between the faults. It's this data that we need to turn into a pillar grid. We start on the left of the tab by creating a new structural framework. This structural framework is in time, and now we need to add the faults. We can add these through the dialog in the tab, or we can simply right mouse on the faults and say fault framework while interpreting. This builds us a structural framework fault set. We can now quality control our structural framework faults. We check that we have good fault intersections shown by the white intersection lines, and if we have anything to change we can use the right mouse button on the faults, which brings up the mini toolbar where all the controls for the faults are located. One of the first things we would like to do is validate the fault model. The fault validation checks all of the connections between the faults, and if there are any errors they will be shown in the structural framework QC manager. Some of these can be corrected automatically and some of them will require manual intervention. We can see the results when we bring up the message log, which now says fault framework is sealed with no errors detected. We now need to set up the boundary for our model. We can build multiple structural frameworks from a single structural model of faults. So setting the boundary condition, this can be picked up from any data such as seismic cube or surfaces. We can just push them in from our input tree, and then we could adjust, for example, the grid increment to one more appropriate. With the boundary in place, we are ready to do horizon modelling. We open the horizon modelling dialog either from the structural modelling tab, or we could be working directly from the faults and choose horizon modelling here. We can drop in our two horizons. We can use multi-drop, and if we like we can change the algorithm settings, but first pass is probably okay to run on the defaults. After the process has run, we'll find that now in the model tree we have our horizons modelled. Let's clear the screen from the Windows toolbar and look at our horizons. We can adjust the color scale using the mini toolbar and look for the quality of the fault horizon intersections. If we're happy with this result, we can now right mouse, relaunch the horizon modelling. We can choose to finalize the model at the final resolution. When a model is finalized, it will include now a zone model. So we could turn on the zone model and look at our final structural model and check its quality. We are now ready to build the pillar grid from the structural framework. We go to the corner point gridding group and select structural framework to fault model. This picks up the structural framework and we can choose what kind of faults we want to build. In this case we're building linear faults. We inspect these faults to see if we've created a good result, so we turn off the structural framework and we can check the quality of our faults. You'll notice that we've got very good fault intersections automatically created, and that the pillars have been limited to the reservoir interval. If we do need to make edits to the fault framework, a simple right mouse on the faults brings up the mini toolbar, and the first tool we see is the Edit Fault Model tool palette. So in this mode we can select faults. For example, we might select this fault and delete it. We might select this pillar and delete it. We might switch a selected fault, or we might want to make it vertical. we can see that all the operations for truncating faults, joining faults, etc. are located easy to access on the mini toolbar. Ctrl Z or undo will remove our edits. Let's perform a couple more fault operations. So if we zoom into this area, we can see that we have a very small fault here, which we use the selector tool and we could remove it. And now if we would like to join these faults together, we can select, using the shift button, the two faults to be joined and simply hit right mouse button, connect faults, and they will be joined together. We're now ready to set boundaries and trends for our pillar faults. So we need a 2D window where we will turn on our fault model. We can use View All from the Windows toolbar, and the first thing we might want is a boundary. We can use the tools directly. For example, we want to create a boundary segment, or we could draw a boundary around the whole model. So let's draw a boundary around the whole model. We're now ready to launch the pillar gridding operation from the structural modeling tab. We're building a 3D grid, and let's keep it at a 40-meter resolution and press apply. And perhaps we would like to set some trends. So again, we simply select a fault and a right mouse button brings up the mini toolbar, and we could set, for example, I trend on this fault and reapply the gridding. If we're happy with the mesh, we can hit OK, and this will build us our skeleton model. We're ready to drop in the horizons, so we choose the horizons dialog and we add in two horizons, and we're going to use the horizons from the structural framework directly as input, adjusting perhaps the fault blanking distance and hitting OK. If we go back to our 3D model, we can now see that our pillar grid has got horizons in it, and if we inspect these using Set Horizon and Fault Visible, we can now check the quality of these horizons, and we have a pillar grid which is ready for layering. So if we insert some layers into here, let's put in 5 layers, and to see this as a grid we will need some geometrical model. So we're going to create a zone index from all K layers, and we now have the property available which can be inspected. Right mousing on this, we can use the functionality hide all but, and all the controls for visualizing are held on the mini toolbar. So for example, we can see the cells. We could choose to look at an eye line, which brings up the player, and we now can pan through our grid to check its quality. Perhaps we should look at a base horizon at the same time, and we can now see that we've created a high quality pillar grid. In structurally complex areas where a pillar grid cannot be built, we would use the structural gridding. This picks up the structural framework, and it's a very simple dialog because we simply have to set the number of layers, and this will build us a stair-step grid from our structural framework. And again, we can inspect this. Let's right mouse on it and show the cells, and let's again choose an eye line, and this is now the active grid, so we can pan through it. We could set the player playing, and you notice that in 2014 the currently selected grid is the one which will be played through. So if I select the other grid, it becomes the active object and so is played. This ends our quick review of the gridding process in Petrel 2014. We have seen how we can build a structural framework from raw seismic data and turn this into either a pillar grid or a structural grid.